Hi everyone, welcome. So today, we're going to tackle a technology that is just absolutely essential if you're serious about building and deploying AI services. I'm talking about Docker. This is the key to getting your brilliant ideas out of your laptop into the real world so you can finally stop saying that one phrase that every single developer hates.
You know the feeling, right? You spend days, maybe weeks, building an incredible AI model. It's working perfectly. And then you try to run it somewhere else, and it just completely crashes and burns. That is the classic, soul-crushing, but it works on my machine problem. So the question is, how do we solve this thing for good?
Here's how we're going to break this down. We're going to follow a simple why, what, how structure. First, the why. We'll dig into the deployment problem itself. Then, the what. We'll cover Docker's core concepts. And finally, the how. We'll map out the entire journey, from writing your very first Docker file to building a reusable pro-level skill. All right, let's dive right into that core challenge, a dilemma that has honestly plagued developers for decades, the works on my machine problem. And look, this is so much more than just a minor annoyance. When the environment on your laptop, your specific Python version, all your library dependencies, your OS, when that stuff doesn't perfectly match the production server, things break. And the real-world cost? It's right here. We're talking catastrophic deployment failures, countless hours just wasted on debugging, and a huge risk to your entire project. So, how in the world does Docker fix this? Well, it all comes down to really understanding three core concepts. Think of these as the fundamental building blocks of containerization.
And this slide just lays it out perfectly with a super simple analogy. Think of a Docker image as your architect's blueprint. It has all the instructions for everything, the foundation, which is like your operating system, to the electrical wiring, which are all your dependencies. The container, then, is the actual house you build from that blueprint. And here's the magic. You can build as many houses, as many containers, as you want from that one perfect blueprint, guaranteeing they all look and work exactly the same.
So how do you write that blueprint in the first place? Well, that's where the Docker file comes in. It's literally just a simple text file. It's the recipe that lists every single step you need to assemble your image, from picking the base OS to copying your code over to installing all those dependencies. This is how you create those consistent, repeatable blueprints every single time.
Okay, so we've got the why and the what down. Now for the really fun part, the how. Let's look at the clear, step-by-step path to actually writing your first Docker file and spinning up that first container.
Learning this stuff is a really structured process. You're not just thrown in the deep end. You start small, with the basics like installation and the fundamentals we just talked about. Then you build your very first Docker file and learn how to manage and debug it. From there, you start to level up with professional techniques like multi-stage builds and production hardening, all leading to a final capstone project where you containerize a real API. Now, building a basic container is a huge first step, don't get me wrong. But to use Docker like a pro, you've got to go further. Let's talk about taking your container from just a development curiosity to a real production powerhouse. That means optimizing and hardening it. Okay, one of the most powerful techniques for optimization is the multi-stage build. It's a game changer. Here's how it works. In the first stage, you use a bigger image that has all the tools you need to build your app. But then, in the final stage, you start fresh with a tiny, minimal base image, and you copy only the finished application into it. The result? A production image that can be 80 or even 90% smallware. And this isn't just about saving disk space. It means faster deployments, a way smaller attack surface for security, and just a cleaner, more efficient final product. Beyond just size, getting ready for production is all about security and reliability. That means doing things like running your app as a non-root user to limit vulnerabilities. It means building in health checks so that your system knows your app is actually alive and working. And, critically, it means managing your secrets the right way with environment variables, never hard-coding them, and knowing the essential commands to debug a container when things go wrong. These aren't just suggestions. They are absolute professional requirements. So we've gone from a problem on our local machine all the way to a production-ready container. But the real goal here, the ultimate payoff, isn't just to build one container. It's about building a skill that you can use over and over again. The source material for this explainer puts it perfectly with this quote. By the end, you own a production-ready Docker capability for your agent services. Pay attention to that word capability. This isn't just about learning one tool for one project. It's about owning a professional skill that you can apply to any AI service you create from now on.
The path to getting that capability follows this really smart 4-layer method. You start with the core foundations. Then you master the optimization techniques to make your containers lean and mean. The third step is key. It's skill design. This is where you go from one-off builds to creating a repeatable, professional workflow. And finally, you solidify everything in the capstone, applying that complete skill to a real-world problem.
So what do you actually walk away with? It's not just theory, right? You get 2 concrete outcomes. First, a tangible, hardened, production-ready container for your API pushed up to a registry. And second, and maybe more importantly, a reusable Docker skill that you can apply to every single project you do from now on. By mastering this, you've officially solved the works on my machine problem. You've packaged your AI service into a portable, reliable, and scalable unit. And that leads to the final, really exciting question. Your AI is now in a container. So where are you going to deploy it next? The cloud? A Kubernetes cluster? That, my friends, is where the next stage of the journey begins.